Hello everyone. Today I'm going to share our intelligent learning application, an AI-powered learning tutor for students and teachers. In many classes, students don't get enough personalized help. When we get stuck, they're often alone. Our idea is to use an agent to act like a priority tutor, and it gives personalized Q&A, exercise, and learning analysis. It simulates one-to-one tutor experience, so students learn faster and more independently. It also helps teachers with grading and class insights. Our platform is an AI-driven adaptive learning and teaching platform, and its core model is with AI interaction energy as a core. And this is the core feature and the technical highlights. The key user groups is about the students and teachers. Students can chat with AI for help, guide exercise and error analysis. Teachers can publish the assignments and use AI asset grading and view class analytics and reports. And this is our future diagram. Our platform have 4 areas. It's the platform governance, learning and assistance, analytics and insights, and the engagement. In platform and government, we have register and login, permission management, student feedback, model feedback, and other.
That is my part. My name is VEDIO, and I will present our use case diagram and structure analysis and design. To answer the question who does what, we've created the use case diagram. Our system serves three main actors: the student, teacher, and tech team. For the student, a core feature is Ask AI Tutor. For the teacher, it's grade assignments with AI. And for the tech team, they are responsible for tasks like optimize AI model, and other functions can be seen as there. For our architecture analysis, we use the 4N1 view model. We've defined the system's functional modules in the logic view, process view for runtime behavior, and the development view for code organization, and the physics view for deployment structure. And the scenarios validates our design to ensure everything works together. Based on this analysis, our design is a classic MVC pattern, but with a key innovation. The model layer is not a simple data handler. It's an advanced AI agent. When it receives a request, this agent uses a plan, execute, and reflect workflow to generate intelligent responses. This creates our powerful MVC skeleton with an AI brain architecture.
Here, we move to the class diagram and object diagram for our learning support system. For the class diagram, the main structure starts with the superclass user, which is inherited by student, teacher, and tech team. This design allows all roles to share basic information like user ID and email, where each subclass has its own features. For example, students can complete practice and submit assignments. Teachers can create and grade assignments, and tech team reviews feedback cases and maintain AI models. The relationship includes one teacher publishing multiple assignments, the students submitting multiple submissions, and submissions linking to feedback cases. Altogether, this diagram defines the logical backbone of the system. For the object diagram, this shows a real example of how these classes interact at runtime. Here, teacher Alice published an assignment called the Machine Learning Lab. Student Alex and Amy each submit their work. One submission is graded, the other one is still pending. The graded submission is linked to a feedback case, which is handled by tech ops from the tech team. Each student also includes their learning history, showing how performance data connects with the dashboard function.
In stage 1, our group members designed 2 diagrams for activity diagrams, sequence diagrams, and state machine diagrams. Because there are quite a lot of diagrams, I can't cover all of them, so I briefly introduce a few representative examples to illustrate our system's behavior. So first, this is AI-assisted assignment grading activity diagram. We can see how responsibilities are clearly divided between the teacher and the system. The process starts when the teacher selects an assignment, then an alternative branch decides whether a reference answer exists. If yes, the AI performs automatically grading and returns draft feedback. Otherwise, it switches to manual grading. And this is personalized practice and error analysis sequence diagram. This shows how the student interacts with the practice service and the AI agent. The alternative fragment separates correct from incorrect answers, while a loop fragment represents continuous practice until the student exists. It highlights how our system supports adaptive learning through repeated question cycles. And finally, this is dashboard state machine diagram. The station begins in idle, loads user data, then moves to a composite viewing state, where the student can switch between charts and AI feedback without leaving the main state. If loading fails, it transitions to unavailable. Altogether, these diagrams demonstrate how each module, from grading to personalized practice to analytics, following a consistent modeling logic. Even though each of us designed different diagrams, they all connect under the same architecture, showing both the functional workflow and the dynamic behavior of our intelligent learning system.
This is our package diagram. It shows the logical architecture of our system. The system is organized into 4 main subsystems: application, data management, AI agent, and external service. The application subsystem handles user interaction and core functions such as assignment publishing, grading, and class analysis. The data management subsystem manages persistent data for users, assignments, and feedback through structured data access. The AI agent subsystem provides service to support functions such as grading and adaptive learning. Finally, the external service subsystem integrates third-party components, including authentication and notification modules. This is our deployment diagram. It shows that user can access the system via a browser on a personal computer or a mobile device over HTTPS. The application is developed with a Spring Boot framework and deployed on the Tomcat server environment. It contains multiple layers such as controller and service layer, plus an LLM connector for AI agent features. The database server runs PostgreSQL, storing student, teachers, assignments, submissions, and other data for the system to use. Lastly, external LLM service provided by OpenAI is invoked through secure API calls to support grading and intelligent Q&A functions.